Now that we know what percentile is, let's figure out how to use it and how to calculate it and figure out what percentile somebody is in. Okay, so we've got this captive gorilla. Her name's Sasha. She weighs 61.8 kilograms. And we're trying to figure out what percentile her weight is. In other words, what percent of gorillas weigh less than her. And that tells us, the area under the curve below her, okay? So this is a normally distributed data set. Gosh, there was that word, couldn't come out of my mouth. All right, it's normally distributed. It has a mean of, so let's go ahead and we'll draw it right here, just so we can think about it. It has a mean of 82.3. It has a standard deviation of 15.33. And so what we notice right away is that she is not exactly one standard deviation away, right? We can use the empirical rule when you're exactly one standard deviation away, or exactly 2 standard deviations away, or exactly 3 standard deviations away. We can use the empirical rule and we don't have to calculate a z-score and we don't have to do this. But 61.8 is not exactly 15.33 standard deviations away from 82.3. So we have to calculate a z-score, see how many standard deviations away from the mean she is, and then we're going to use our calculator to figure out the actual area under the curve. So let's calculate the z-score first. So remember, we take the value, which is 61.8, we subtract 82.3, which is the mean, and we divide it by the standard deviation because we want to see how many standard deviations away from the mean she is. So here's we put it in and we get a z-score of negative 1.337. Now remember, we can have a negative z-score. That means that she's 1.337 below the mean, right? 1.337 standard deviations below the mean. That makes sense because she weighs less than the average gorilla. So now we're going to use our calculator to figure out where that actually falls on the curve and how much of the curve is below her. So there is a little bit of a learning curve on this one. If you have an older TI-84 and you haven't updated the operating system, let's talk and see if there's a way we can get you updated, because once you update it, it's a lot easier. Oh, excuse me. But if not, there is a way to do this, and I believe I linked a video in another slide that shows you how to do this if you don't have the newest operating system on your calculator, but this is pretty easy. Okay, so the first thing we're going to do is we're going to go to second and we're going to go to distribution. See, it's above this button that says vars, distribution, because we're talking about distributions, right? The normal distribution, so we're going to go there. And we're going to use this NormalCDF. You'll notice there's tons and tons of other ones here. These are all different types of distributions that we're not learning about in Algebra 2, but these do exist in statistics, chi-squared and t distributions and so on and so forth. Those are lots of different distributions that we could use to calculate. But in this case, we don't need to. We're talking about the normal distribution. So we're going to go to normal. And we never use PDF, we use CDF. You don't need to know why. It's not a big deal. Just use CDF, okay? Here we go. Enter. So this is going to tell us how much, what percent of data values are going to be in between 2 values. So what we're basically doing is, let me show you. Maybe I can draw it here. You have a curve, okay? You have this curve. And you're saying, I want to see what percent of my values are between here and here on the curve. Right? And they don't have to be symmetrical. This could be like 1.5 standard deviations away, and this could be 3 standard deviations away, or 3.7, or 3.73, 4, 2. Like this could be literally any number, right? We want to see what's the area under the curve for this, which basically means how many of my data values are in between negative 1.5, and 3 point whatever. Or in our case, we're looking at it in this way. We're saying, here's our normal curve. Oh, that's not a straight line. Okay, here's our normal curve. And here's Sasha's weight. We know that it's below the mean. And we're trying to figure out all the area under the curve to the left of this, all all the way down, right? We don't really have a lower bound. We want to go all the way down the curve. We want to figure out what percent of gorillas have a weight that's over here, okay? So what is our left bound? Basically we're saying let's put a left bound and a right bound on this area. But in this case, we don't have a left bound because we want to go all the way down to like the tiniest little, or the biggest negative number we can, right? We want to go all the way to basically negative infinity. So how do we put that into a calculator? Well, luckily your calculator already knows that's probably what you want. So it automatically puts in -1 e to the 99, which means -1 with 99 zeros after it. So this is almost -1 Google. It's a huge negative number, right? It's such a huge negative number that it basically means negative infinity. So anytime you want infinity or negative infinity, you're going to put this. You're going to put -1 e99 if you want negative infinity. If you want positive infinity, like if you want to go all the way as far positive as you can, instead of negative, you just make it positive. So that's our lower bound. Our upper bound is Sasha's weight, right? We want to see how much is in between negative infinity and 61.8. We want to see how many gorillas have a weight in between negative infinity and 61.8. Our mu, or our mean, is 82.3, and our standard deviation is 15.33. Okay, now you just go down here to paste. You just push enter. Paste, and it just pastes this whole thing in there for you in the right order, so you don't have to figure out how to do the order, and you push enter, and it just tells you that 0.09 blah 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 is the normal CDF for this. So what does that mean? This is a percent, right? This is a decimal, and if we convert it into a percentage, this tells us what percent of gorillas have a weight that is in between negative infinity and 61.8. So to convert to a percentage, remember we just moved the decimal place 2 places. So we have 9.057%, let's call it that, 9.057% of gorillas have a weight that is in between negative infinity and 61.8. So, in conclusion, 0.57? I already forgot. Okay, I was right. 9.057% of gorillas have their weight below Sasha's weight of 61.8. So if we asked what percentile is Sasha in, well, she's in the 9th percentile because about 9% of gorillas have a weight that's smaller than her. Therefore, about 91% of gorillas are actually heavier than her.